We already covered one double underscore or Daunter method. Let us try to use one more Daunter method before we proceed further. As and when we require to use double underscore method, we'll be dealing fundamentals of it. Right now, we'll just be going through an equal method which is used to check whether two instances of a class are equal or not. So the Daunter method for it is equals to. We proceed like this, double underscore, then we have an equal method where first argument is the self and second argument is the class input that you'll add. So let us just name this as class scene. Here, user wish to check whether both the instance are equal. That is, both are of same type and the data member present in both the classes have same value. In that case, we can say both are equals to each other. So we need to provide an implementation of it. So we proceed like this. Let us assume we do not provide any implementation. Then in that case, we will be getting a warning like this. Let us just add first instance of a temp. Here we'll use the default value and the second instance of temp, which we named as a T2. Now we check whether both of these instances are equal. In fact, since we have not provided any argument, both of the instances are of temp type. This match the first condition, and second, both the data member will have the default value of 10 and 20. Both of these instances are equal. So if we proceed like this, T1 dot, now we access equal method and provide T2 as the second instance. Now if we try to execute the code, we get none. So this method do not do anything because we haven't provided an implementation of it. Or if we just remove this from the temp and try to again execute the code, you could see we get the message as not implemented. We haven't provided an implementation for the double underscore method. Now we proceed and try to provide an implementation that will compare whether two instances of a classes are equal or not. So we start with a double underscore equals to method. The second argument is other, or you would just rename it as an class in whatever other instance of a class that user will provide. Here we need to do two check. First one is whether the other instance of a class is of temp type. So to do that, we have an inbuilt method is instance that could be used to check whether the variable or a class provided is of specific type. For example, we could provide a variable a and then we specify type to be integer. So here we are comparing whether a is of an integer type. If this is true, it will return true, else it will return false. Here, our agenda will be to compare whatever class instance user provide is of temp type or not. So we proceed like this, the class instance that user provide, and it should be of temp type. If this is true, then we proceed further. This is the first condition that we need to check. Then the other thing is, as soon as our instance is true, we will verify whether data members that we have in a class have the same value as compared to the instance of a class with which we are comparing. So how we proceed? So here we again use an if block. Now self dot a, which is the value of a data member in the instance we are comparing, should be equals to the class in a value. This is the first condition that need to be true. Second condition is the other data member of the instance of the other data member B should have the same value as the data member of a class A. If this is the case, then both the conditions are matching. That is, class instance that user have provided is of temp type and both the data member also have same value. In that case, we will return true, else we will be returning false. So any one of this condition fails, we'll simply return false. So this is an implementation of our equals to method. What we are doing over here, we are checking whether the instance user have provided is of temp type and all the data members of a class have a same value compared to an instance with which we are comparing. So here we have added two instances, T1 and T2, without providing an argument to A and B. So this will create T1 of temp type and initialize data member to 10 and 20. Likewise, we will create an instance of a T2 and will initialize A and B to 10 and 20. So both of these are of temp type and both have same value for data member. So if we call T1 equals to T2, this should be true because both are of same type and all the data members are equal. So you could see we get the value as true. Now, if you try to use different value, for example, let us use 3 and 4 for T1 instance and 5 and 6 for T2 instance. Now you could clearly see both are of same class type, that is temp, but the values of data member are different. Hence, if we call an equals to method, it should return false. We'll proceed and try to execute the code, and you could actually see we get false. So this is how you override and double underscore method and provide an implementation to it. These are quite useful. We'll understand the usage of double underscore method as we progress further. But with this example, now you understand two double underscore method in it, which could be used to initialize the data member of a class or something that we need to do while creating an instance of a class. Equals to method can be used to check whether both the instances of a class are equal, that is of same type, as well as all the data members have same value. So this could be used in a scoreboard where we generate the expected response for the output and which we store in an independent instance of a class. Likewise, we have one more class which collect the response of the DUT, and we could just compare whether both the classes have same values for a data member utilizing this method. So this is one of an immediate usage of an equals to method. We'll understand more on this as we build our verification environment.